it's Elke Wind, just like the wind that blows, easy to remember. In terms of my interest in amphibians, it really just actually became about because I was applying to 3 different grad schools, and it was just a matter of the funding came through for the amphibians first. So that's just what I went with. It didn't really matter to me what group it was going to be, moose or bats or amphibians. So it's not like I've had a lifelong love of amphibians necessarily. I've just really liked the project that came up for my graduate work. So, and then I got into the field just at the right time, I guess, when there was a lot of interest in amphibians. So the work just kept coming, and I've managed to just stay sort of focused on that one group. So become highly specialized, which is interesting, but limited in some ways. So let's see if I can share my screen here. All right, so when I'm in share mode, I cannot see any of you guys. So if anything comes up, just jump in and let me know if anything happens. If you can't hear me or something, just let me know. So the talk today is why did the salamander cross the road? And I'm going to start off at sort of basic biology 101 because I don't know where everybody is when it comes to their knowledge around salamanders. So we'll break it right down into what exactly is a salamander. And we'll talk about where they live and what they're doing in different habitats, because then that relates to the next topic, which is what they're doing on roads and why they're going onto roads. And then to end on a more positive note, I'm going to touch on some of the mitigation that's taking place around roads for amphibians, and also some salamander monitoring programs that are taking place. So salamanders are within the vertebrate group amphibians, which are a very old vertebrate group. Their fossil record goes back around 370 million years. And they're believed to have evolved from a fish that had lungs and sort of fins that were like hands, and they were able to come up onto land. So at this point, there had been no vertebrates on land. So these are the first vertebrate groups to come up out of the water. And then the evolutionary step from there was the reptiles, which moved into even drier environments by developing scales and having shells on their eggs. In terms of the numbers, we have about 8,000 amphibian species globally, and 90% of those are frogs. Amphibians are broken into 3 main groups. The Anura are the frogs and toads. The Caudata are the salamanders and the newts. And then you have the Gymnophiona, which are the caecilians, which we don't have those here in BC. There are 21 native amphibian species in British Columbia. And in the lower mainland where you guys are, there are 11 native species and 2 exotics. And here on Vancouver Island where I am, we have 9 plus the same 2 exotic species. In this table here, which is the amphibians for the lower mainland, you can see I've got them broken down by those 2 big groupings. Let me just go back through here. There's the outline that I mentioned. We're going to just talk generally about amphibians first, where they live, what they're doing on roads, how we're mitigating the effects of roads, and some monitoring programs. Just going to go through this again really quickly now that you can see the slide. We have some latecomers here. Salamanders are in the amphibian group. It's a very old group made up mainly of 3 groupings: the Anura, frogs and toads, the Caudata, salamanders and newts, and the Gymnophiona, the caecilians. So this is where I was just talking about the number of species that we have in the lower mainland and on Vancouver Island. This table here is for the lower mainland. I've got the amphibians broken up into those 2 main groupings that we have, the salamanders and the frogs and toads. You can see we have slightly more salamanders than we do frogs and toads in the lower mainland. And we have the 2 exotic species listed in the bottom. The provincial and federal status columns are on the right-hand side. You can see you've got 2 blue listed species, 1 frog and 1 salamander species, and the red listed Oregon spotted frog. The key characteristic that ties all of these different species together for amphibians is the fact that they have this very unique sensitive skin, this permeable skin that allows liquids and gases to pass through freely in both directions. All amphibians can breathe to some degree through this permeable skin. And for that process to be effective, for it to work, the skin has to be moist. So that basic characteristic of amphibians sort of affects everything about where they live and what they're doing. So they're very sensitive to extreme climatic conditions, to any types of extremes in heat or drying in particular, but they're also very sensitive to freezing, so on the other end of the spectrum. And so as a result, they tend to live in vegetated areas, or they stay very closely tied to water. And then the other option is they spend a lot of time underground, some of the species. All of the amphibians as adults are carnivorous. These two groups, the anurans and the caudates, the main differences between them are the fact that the salamanders have a much more elongated body. They have a tail, which they have the capacity to drop if a predator is going after them, and they can regrow it, but they store all of their fat in their tail. So that's a very costly endeavor to drop their tail or to lose their tail. So you never want to handle an amphibian, same with the reptile, by their tail. And then, of course, the legs are quite different with frogs and toads versus the salamanders. The frogs and toads are using their hind legs for swimming and for jumping, and so the legs are much longer and they tend to have webbed feet. The legs of the salamander are far more dainty, and then combined with those small limbs, they have this sort of laterally compressed body. They're very flat-like in their shape so that they can get into small spaces and crawl into crevices. The anurans, the frogs and toads, tend to vocalize, so they're communicating vocally. So they have a well-developed eardrum as a result, whereas the salamanders don't communicate using sound, so they have far less developed ears. The frogs and toads have external fertilization, whereas the salamanders have internal fertilization. But it's not internal fertilization as it is with mammals. The male salamander drops a spermatophore on the ground and the female is able to pick it up and then fertilize the eggs internally that way. And then the frogs and toads have what we call a biphasic lifestyle, where the young are inhabiting a very different habitat from the adults, and they also look and behave quite different from the adults. And when they go through metamorphosis, that's when they're changing the way that they breathe, what they're eating, and where they live. And then that's when they start to look more like the adults. Whereas salamanders, we have both biphasic and monophasic lifestyles. So you have the same as the frogs and toads, where the young are looking very different and living in a different environment. And then we have some of the salamanders where the young have direct development and they're hatching out of the eggs looking just like the adults. So I'm just going to go through the two main types of salamander groupings that we have in the province. We have the aquatic breeding species. And because these guys are breeding in water, needing to lay their eggs in water, they're making these annual migrations to and from these breeding sites and then back onto land to get to their overwintering habitat. And then again, they have this biphasic lifestyle. And I don't have any images of the actual sort of detailed courtship that the salamanders do. It's quite interesting. But they're basically, with these aquatic breeding species, they're coming together in late winter and early spring, laying their eggs in water attached to some sort of vegetation or debris. And then you have this aquatic larval stage that looks, as I mentioned, quite different from the adults. These guys have external gills, and the front legs are developing before the back legs. So if you're ever seeing larvae in water, those are the two characteristics that you first want to look at to tell whether you have a salamander versus a frog or toad. If you have external gills, if you can see the gills, then you have a salamander larva. If you can't see the gills, then you have a tadpole, which is, we tend to distinguish the two groups by calling they're all larvae, but we call the larva of the frogs and toads tadpoles, and the larva of salamanders we call larvae. And then what's also interesting is with the tadpoles, their back legs develop first and then their front legs. So they have very different development between the two groups. And at some point, they will metamorphose into a form that lives on land. But this time period between when they're an aquatic larva and when they go through metamorphosis varies quite a bit from species to species. Some of them will metamorphose in the same year, and others, like the northwestern salamander, take more than 1 year before they go through metamorphosis. And what's unique with the northwestern salamanders is they may not actually go through metamorphosis. So they may retain some of their larval characteristics, such as the gills, but they'll reach sexual maturity and they will remain aquatic. Not all of the individuals will go through that sort of altered development. And so we have two different adult life forms within that species. We have an aquatic form and we have a terrestrial form. And they don't really understand what causes one to change and the other one doesn't. And they also don't know if it's permanent. If they become what's called pedomorphic or neotenic adults, where they're retaining their gills, we don't know if, for example, if the water body started to dry, would they be able to metamorphose still? These are examples of the aquatic breeding salamanders that we have here on the south coast. This is the northwestern salamander in the top left, which is the one I was just talking about that has two different adult life forms, one that's what we call permanently aquatic and one that is terrestrial. And then we have the rough-skinned newt and the long-toed salamander. So these are all salamanders that breed generally in standing water. And then we have the coastal giant salamander, which only occurs in Canada in the Chilliwack Valley in mountain streams. So it's a very small range here in Canada. And they're a beautiful salamander. They're very large, quite dominant predator within those aquatic systems. So then the second group we have are what we call the terrestrial breeding salamanders. And these guys live 100% on land. They never need to go to water. And in fact, if one is to actually fall into water and isn't able to get out, like all amphibians, if they can't escape water, they can actually drown. It's not a good situation for them because of that permeable skin. And the terrestrial breeding species lay their eggs on land, generally under logs, rocks, or underground. And they have that monophasic lifestyle. These are three examples here. We have the western redback salamander and the ensatina. Those two species occur all through the south coast. And then the wandering salamander we have here on Vancouver Island. The wandering salamander is a really interesting species because they have squared off toes and they're able to climb. And they have another closely related species down in California that can climb way up into the redwood trees. Our wandering salamanders will also climb up into trees. So they're quite different than the other two terrestrial species, which tend to spend their time underground. The monophasic lifestyle, again, unfortunately, I don't have any images of terrestrial salamanders when they're breeding. It's obviously pretty difficult to get that. Most of the images come from laboratory studies, but they have this very interesting, quite detailed courtship that they follow. And this is the time of year actually when terrestrial salamanders are breeding. It's in the fall. Once it becomes rainy, that's when they're active at the surface again, and then they're out looking for mates. I snagged these two pictures of these ensatina here, which is one from California, where Joe Garcia was under his house and there was some wood on the ground. And when he lifted up the wood, there were a number of these ensatina females guarding their eggs. They keep the eggs clean while they're developing, so they protect them from any sort of infections. And then he returned and was able to actually capture basically the little juvenile ensatina as they were hatching out. So you can see they have a direct development. When they come out of the eggs, they just look exactly like the adults. The aquatic breeding salamanders, as I mentioned before, they're laying their eggs in water, but they will take advantage of quite a wide variety of aquatic sites for laying their eggs. They'll go to natural water bodies like lakes, wetlands, ponds, and very slow moving streams or side channels. Their tepals are not developed to be swimming in water with a current, so they're not really, they don't really survive well in streams. And then they'll also take advantage of artificial or man-made sites. So roadside ditches, golf course ponds, stock ponds, stormwater ponds, all these sorts of things. And also we find them in water bodies associated with different industrial developments. But both the terrestrial and the aquatic breeding salamanders, outside of that aquatic breeding season, they're both found on land. So all of the salamanders are very dependent on forest cover and vegetated areas where they're spending their time under cover, under logs and rocks, or underground. So this stump that you've got here on the bottom left of the screen is just an example of how a lot of the stumps here on the coast, they will rot from the inside out. And we did a study on western toads, tracking them to their winter hibernation sites. And a lot of them went into these hollowed out stumps. And as you can imagine, if it's rotting from the inside out, all of the big root channels that go down into the ground end up acting sort of like straws. So they're perfect little tunnels that will get them down underground, because none of these species can dig their own way down. So they're dependent on other crevices and cracks that lead them down underground. When we set cameras up at the stumps that the toads had gone down, we did capture lots of other species that were taking advantage of these rotted out stumps, and we did catch salamanders as well. But just like the aquatic breeding salamanders, when it comes to breeding in artificial water bodies, these salamanders will also take advantage of artificial or man-made sites on land. So if you've ever taken apart a wood pile or been clearing up debris, woody debris on a yard, you may have come across salamanders underneath the wood. They might also go under your shed and that sort of thing. They're just looking for places to hide during the day, and then in the winter or the extreme heat of summer, then they're looking for places to get down underground. Some of the most interesting things about salamanders is that they're relatively long-lived. The terrestrial salamanders, for example, some of them can live for about 25 years, which is quite a long time given their size. For their body size, that's very long. They also tend to not move around very much. Ted Davis, who conducted his PhD work here on Vancouver Island, he was marking terrestrial salamanders and then doing a mark recapture study. He found that about 94% of the wandering salamander, the recaptures of the marked salamanders were less than 10 meters apart. So they were moving very little over the number of years of his study. And then what's super interesting is that these salamanders can occur in really high densities. Again, Ted Davis's work, he found that on Vancouver Island, one area of Goldstream Park had a really, really high density of western redback salamanders. But he was comparing across a number of different forest sites on the island, and he came up with an average of about 0.1 western redback salamander per square meter. There's a similar species out in eastern North America called the eastern redback salamander. And in New Hampshire, they estimated the biomass of the terrestrial salamanders. So the biomass is like the total amount of meat, let's just say, of all of these salamanders put together. And they found that the salamander biomass was about twice that of the birds in those same areas during the peak of the breeding season, and about equal to that of small mammals. So they're quite numerous out in the landscape, but we don't pay a lot of attention to them. We don't see them. So we have no idea that they're even there and in that sort of density. So it's keeping those density numbers in mind. You can imagine that they're particularly sensitive to development, given they're not moving around very much and they're very forest dependent. This is an example of a development that is about to take place here on Vancouver Island. It's 726 acres, so it's over almost 3 million square meters of forest habitat. So when we do the math at 0.1 western redback salamander per square meter, that means that almost 300,000 western redback salamanders potentially occur in that forest habitat, and those will be lost as a result of development. There's potentially going to be small pockets or little remnant pockets of forest left throughout this development, but those salamanders that do manage to survive in those little remnant pockets are going to end up surrounded by by development and roads. When it comes to industrial work, so I've been working up on pipelines and various industries such as that. There's a practice now where we go out and we actually salvage amphibians. We try to catch as many as we can and we move them out of the way of the construction project. But we're largely doing this for aquatic breeding species. They're much easier to catch. It's easy to catch tadpoles and larvae at the water bodies. So amphibian salvage is taking place in certain conditions, but this isn't really possible to do with terrestrial salamanders. Ted Davis, again, with his work, he estimated that less than 24% of the terrestrial salamanders are at the surface at any given time. So you've got these small, dainty little animals. Most of them are underground. They're only at the surface for very brief periods in the spring and fall. It would be extremely labor intensive to try and salvage the terrestrial salamanders in the face of development. So you can imagine from the example that I just gave that it's easy to understand now why salamanders end up on roads. We've got the aquatic breeding salamanders that have to migrate to these water bodies to lay their eggs, and then they have to get back to upland habitat to find suitable habitat to overwinter. And they have to make these migrations every year. As well, the juveniles, when they're coming up out of the water body, also have to make their way into the upland environment. So we have sort of 3 different annual migrations or dispersal events going on throughout the year for the aquatic breeding salamanders. And then the terrestrial salamanders, as I mentioned, are looking for mates in the fall. So that's when they're active at the surface and moving around a little bit more than normal. The young of different species, occasionally you will have a young that will make fairly large movements as they're dispersing into a new environment, which is, of course, very important for maintaining the genetic diversity within the different populations. So all of those different events and different species need to be able to make movements across the landscape. But these migrations and dispersals can be hundreds of meters to kilometers for some of the aquatic breeding species. And if there's a road positioned somewhere in there, then they're going to have to cross it. And the road does not act as a barrier to movement for amphibians. They will attempt to cross it. And in fact, for some species, roads are looked at as basically a unique ecological habitat, especially for the amphibians, because the ditches along the edges of roads will hold moisture or even standing water at certain times of the year that the amphibians might take advantage of for as a movement corridor or to lay eggs. Roads provide unique thermal conditions. So if you're a salamander that's active at night, when you go out onto the road after sunset, the road will be warmer than the surrounding environment, and it gives you an opportunity to warm your muscles up and to warm your body to make it easier to digest your prey. So salamanders are ectothermic, they're cold-blooded animals, and so their body temperature reflects whatever the environment is. So opportunities to be able to stay moist but still warm your body up, like flattening yourself onto a road before you start foraging at night, is something that they'll try to do. And then, of course, because the shoulder and edge of roads is usually a very different environment than the surrounding forest, there's often different prey available in those environments. So some amphibians can potentially be attracted to roads because it is so unique. This photo here I just snapped, I think, a week or 2 ago. This is right near my house, and this poor rough-skinned newt I found just sort of clinging to the top of the curb, and you could see it sort of looking across the road thinking, I really want to get to the other side of the road, but I'm not sure I want to have to drop down off this big curb. The rough-skinned newts, in my experience, I think they're actually particularly sensitive to roads for 3 main reasons. They don't reach sexual maturity for about 5 or 6 years, so they have a long time to just wander around in the upland environment before they ever need to go back to water to breed. So I think they probably could cover quite big distances over that time. And the rough-skinned newts have, they're highly toxic. They have a teratotoxin similar to pufferfish. So they're okay with moving during the day. They're not worried about things eating them. Really, the only thing that can eat them are garter snakes. So they are out during the day, which of course is also when we have the most traffic. And unfortunately, they move incredibly slowly. When I've been doing some road surveys, I've seen one on a road and I've just sat for a while watching it, just making sure that a car didn't come, but they just absolutely will not move. They will just sit on the road, whether or not they're taking some sort of advantage of the thermal conditions I was just talking about, or I'm not sure what they're doing. But most other species, when they're on the road, they tend to just keep moving and cross, but the newts just tend to sit there. So really vulnerable to any vehicles that come by, even on very low traffic roads. So unfortunately, because these amphibians have to make these big movements, we have thousands of amphibians that are killed on our roads each year. But on a more positive note, there are efforts being made in a number of different places around the world, including here in BC, to mitigate the negative effects of roads and try and reduce road mortality for amphibians and for reptiles. They're often done at the same time in a lot of different situations. And the BC government, I worked with them and a couple of other co-authors in the last few years to develop some guidelines for amphibian and reptile conservation during road building and management activities that was geared towards any sort of road managers within the province. So we are making an effort. These locations here on the map show where we do have some road crossing structures that have been put in for amphibians and or reptiles. So I'm going to just focus in on the project that I've been involved in for quite a few years in the Duncan area. We knew that we had, this is an aquatic breeding site that has actually all 6 of the aquatic breeding amphibians on the island are all breeding at this site, which is incredibly unique. I don't think I know of any other site on the island that has all 6 aquatic breeding species. And we knew that we had lots of amphibians on the roads adjacent to this breeding site, especially western toads, because with the western toads, it's very obvious when amphibians are being killed because the tadpoles, when they metamorphose, they all metamorphose at the same time. The tadpoles are schooling together, and when they metamorphose, you get thousands and thousands of little toadlets all coming out onto land at the same time, and they tend to stay together and move together. So if you have a road near a toad breeding site, you'll end up with lots of toadlets on the road, which tends to get people's attention. So we engaged with the Ministry of Transportation and started doing road surveys here. And you can see on the top, I've got a starting point there, a white dot. And in the center on the right is the end point of the road. And I would alter the start and end location and just walk along this road. It's about 1.5 kilometers approximately. And I conduct those surveys on mild, wet evenings in the spring and fall. That's when those migratory periods occur. Start approximately 1 hour after sunset because most of these species are nocturnal. When I came across an amphibians, I would identify the species, the life stage. I would mark its location, record whether it was alive or dead. And once we had a couple of years of data, then what we wanted to do was figure out where the crossing hotspots were, so that if we wanted to put in underpasses for amphibians, then we would be putting them at the most effective locations. So we focused these hotspots on where the western toads and red-legged frogs were being found. But it would benefit all of the amphibians ultimately in the end. This diagram here, I just limited it to the salamanders. So all of the different colors represent different species, and you can see right from the get-go that the majority of the dots are all one color. I see them as pink. Hopefully everyone's seeing that as pink. And those are the rough-skinned newts. So you can see really high mortality rates or incidence of at least salamanders on the road tends to be the rough-skinned newts. But we have all of the 6 different salamander species have been found on these roads. So after we had the data, Ministry of Transportation was willing to put in underpasses at the sites that we recommended. And so we installed underpasses with directive fencing at 5 locations along these 2 roads. And then I've been conducting effectiveness monitoring of those underpasses. And we followed an adaptive management approach. So with the idea that we're putting in some underpasses now, we're going to monitor them, and then we're going to make adjustments in the future as needed. In terms of how these underpasses were designed, they are dual-walled HDPE, so plastic pipes that we put into the ground. And then some of the pipes were ripped in half and put into the ground to act as directive fencing to guide the amphibians towards these underpasses. And this is just a schematic here of the side of how these fences work, because what we did is we anchored them to large boulders on the backside, and then we backfill the backside with soil, because if we end up with amphibians on the road behind these fences, this fencing occurs on both sides of the road, we don't want the salamanders to get trapped or the amphibians to get trapped. So by backfilling this, then if they come in this direction across the road, then they can drop down and fall into sort of the safe zone behind the fencing. This shows where we put those underpasses. Again, this is the breeding site, again, just zoomed in a little bit more. So you can see we've got 1, 2, 3, 4, and 5 underpasses. The red lines are where the directive fencing is. So you can see they're generally following a little bit of a U shape, because we want to guide the amphibians towards the underpass, which is at the tightest point in the U. But I want to point out here that when we did this design, we left gaps in between. I didn't want to have continuous fencing all the way along. One of the reasons being this is private land on this side, and this is the CVRD park, and there's actually not a lot of room here between in the upland environment and when it becomes aquatic. And because we need these fences to be curved, it's difficult to try and have fencing come all the way along and still have that sort of curved shape without going too far outside of the road right of way. So we left it in this sort of configuration. And again, we're monitoring it to see how well it's going to work, and then we can adjust in the future. I didn't want the fencing also to go all the way across, because it's quite a significant barrier to a lot of different animals, and predators can start to queue in to these underpasses. So if it was fencing all the way along, and certain animals can only get through the underpasses, then predators can start to hang out in those environments. So I wanted to make sure that there were still some open areas for different animals. The diameter of the pipes varies from just under 1/2 meter to almost 1 meter in diameter. So the effectiveness monitoring that we've been conducting consists of 2 main things. One is repeating those road surveys I did before the underpasses were put in, so I can make direct comparisons of pre and post study. And we've been doing road surveys in the spring and the fall, but I'm focusing more now on the spring, because that's when the adults are moving. The fall is generally more the juveniles that are dispersing away from the water body. The adults are really important to the population. They're the ones who've made it through that first difficult year where your survival rate is extremely low. So they have a much higher natural survival rate now that they've made it past that first year. And once they've reached sexual maturity, they're very valuable, especially the females, to the population. So I want to make sure that these underpasses are most effective for the reproductively mature females. The second way that we monitor the effectiveness is using wildlife cameras, and we install them into the opening of these underpasses. We created a mounting system here that can swivel so that I can turn the camera around and when I need to change the batteries, etc. And they just sit looking down into the pipe. Now, cold-blooded animals, like amphibians, don't trigger the motion trigger of a wildlife camera, so we have to set them to motion trigger so that we can detect any of the potential predators that are moving through, but also we set them to what's called time lapse, and that's just taking 1 photo every minute from approximately sunset to midnight, which is when most of the animals are moving. So that means I have a lot of photos to go through. I've had some of the Cowichan Valley naturalists help me go through some of those photos because it's quite a time-consuming thing. I'll show you some examples in a moment. In terms of our effectiveness monitoring results, we have confirmed via those wildlife cameras that amphibians are using the underpasses, which is fantastic. Here's an example here. So this is what it looks like looking into the pipe at night. And these cameras tell us, you know, on what day and at what time we're seeing animals. So you'll see a little red circle come up. So there's a salamander that's just come in here. And then it moves ahead and walks a little bit farther. So if the camera is set up properly, I can get multiple images and confirm that the animal is moving through. So the second thing we're looking at is, are we actually seeing a reduced number of amphibians on the road? So when I compare, I create polygons. So if the underpass is through the center right here, and and the red are the fences, what I did was connect the ends of the fences on both sides. This is a better example here. Connect the ends and create sort of a polygon. And so I could compare this section of road within this polygon, the data that I get on that section of road from before we put the underpasses in until after the underpasses were put in, to see if I'm getting fewer amphibians where we have underpasses. And I do in fact see fewer amphibians in those road sections where the underpasses are. However, I'm getting more amphibians in these gap locations between the fences. So that makes me worry or wonder that the amphibians are hitting our fences, turning away from the underpasses and coming around. And so they're being kind of funneled towards these gap locations in between the underpasses. The other thing is with the cameras, we are able to see when animals look like they're showing some hesitancy to go through or turning around. So from the camera images, we see that about 5 to 23% of the amphibians are turning around at the entryway, or they're going partway into the tunnel, into the underpass, and coming back out again. But this turnaround rate varies by the amphibian grouping and the life stage that they're in. So the blue bars are for spring and the orange bars are for fall. So the orange bars are more the juveniles and the blue tends to be for the adults. So our lowest hesitancy or turnaround tends to happen for frogs and toads in the spring. So that's good because that's the adults of those listed species that we're most concerned about. So this would include, the western toads and the red-legged frogs. The highest turnaround rate tends to be for the salamanders, especially the juvenile salamanders when they're moving in the fall. So we have fairly high turnaround rates. So they seem to be a lot less hesitant, or a lot more hesitant to go through these underpasses. And I'll just show you an example here. Again, this is an image of an underpass of some of this hesitancy. So we have a salamander here that just came in. You can see the tail and the, in the eyes. Just going to go back. It's hard to see. Hopefully you can see that. And then we see it here facing sideways. So it's starting to already show some hesitancy. And then in the next image, it's back here and I'm only getting the tail. So it has decided to turn around and leave the underpass. So that's what I'm seeing as underpass hesitancy. But this turnaround behavior, interestingly, doesn't seem to be related to those, to the width, the diameter of the underpass. So I've put the underpasses in order here from the narrowest to the widest. So it's almost it's exactly twice as wide, the largest underpass. If we were seeing hesitancy in relation to the size of the underpass, so a smaller underpass makes them more uncomfortable, then we would expect the line to go from high in the left and low on the right. But you can see as they go across, we're not having that trend at all. In fact, our highest hesitancy is in the largest underpass here in the fall. So they seem to be comfortable going through smaller underpasses and wider ones. So it's something else that's upsetting them. So again, we're following an adaptive management approach. So we are putting some funding in for 2024 and for 2025 to make a number of little adjustments to our underpasses. One of them is, this is actually taken from the best management guidelines that we've come up with for roads. It is recommended that you curl the end of this directive fencing around. So as the amphibians are approaching this directive fencing, so if the water body is down on the bottom here, they're heading up towards the road. When they hit this directive fencing, you've got a 50-50 chance that they're going to turn left or right. If they're turning away from the opening of the underpass, they're moving away. If they hit this curl around spot, then hopefully it will guide them back and they'll start heading towards the entry. Right now, the ends of our fences are just they're just flat. So that's one of the things that we're going to do is put in those curled ends at the end of the fencing. The second thing is the salamanders could be moving along the wall. They could turn towards the opening, which is great. That's what you want. But then they could actually move right across the opening and then just continue along the fence. So this is a underpass in Europe, and they put in a barrier in the center between the two fences so that you can kind of discourage that movement straight across from one fence across the entryway to the other fence. So we're going to do those two modifications. The third thing we're going to do is we're going to experiment with playing around with the conditions within the underpasses. So I want to add moisture to some of the underpasses. So we'll literally be spraying water in and making the substrate inside the underpass wet just before the migration period starts. And also put in some artificial lighting and see if that helps, if it encourages amphibians to go through. They've played around with lighting at other underpasses and it has made a difference for some wildlife. So we're going to do those two things. And then lastly, Ministry of Transportation has committed to installing additional underpasses, especially on the one road that at this point only has one underpass. So we're working on it. We're continuing to work on it. So that's what we're doing. What are some things that you can do if you're interested in roads and amphibians and salamanders? We started thinking about amphibians that might be living in the urban environment. Salamanders are active at night, and then they're seeking cover during the day. So they're foraging at night, and then they're almost like werewolves, or is it vampires? When the light of day is coming up, they want a place to hide out during the day. And so the Nanaimo Area and Land Trust, I was working with them, and they engaged 2 of the local schools here in Nanaimo to start an amphibian monitoring program using cover boards. So cover boards are something that we use to survey for salamanders. And that's just taking advantage of that natural behavior that the salamanders have of seeking cover during the day. It's a really passive way of sampling for salamanders, and it's great to engage with school kids. This school here in Nanaimo has a little forest patch right in front where there's a creek running through, and there's a stream keeper group that takes care of this, and that's sort of how the Nanaimo Area Land Trust was involved. They were coming across salamanders on occasion when they were working along the stream, so that's sort of where this whole program sort of got kicked off. So what we did with the school kids is we put in 5 transects, and each transect has paired cover boards at different distances apart. I think this whole width here is maybe about 40 meters all the way. And so we have sort of a opportunity for a 2-way comparison here. We have boards that are closest to the stream versus farther away from the stream. And then we also have cover boards that are near forest edges versus in the center of this forest patch. So we're able to do sort of a 2-way comparison of the data. So the students helped install the cover boards, and they absolutely love this project because it's just right outside their doors. And there's about 36 boards out there, so it keeps the class busy for at least an hour. The boards consist of one large, relatively thick chunk of wood on the bottom, and then 2 thin boards on top, or thinner boards on top. And there's a piece of lath that sits on each side on the top, so that the top boards are angled slightly in towards the center so that when it rains, the moisture is being led towards the crack in the middle so that it keeps the bottom board wet. And the students go out in the spring and the fall and they check the boards once a month. We don't want them checking them too often because we don't want the salamanders to get discouraged away from the boards. And they're actually recording the data and keeping track of everything. The teachers make sure that they target dates that are relatively mild and rainy for these board checks. So it's been really interesting I've just gotten hold of the data from them in the last week and just wanted to be able to see what was going on there. This shows the dates that they've checked the boards at that particular park. You can see there are a few in the spring, some in the fall, back in the spring, and up into the fall again. So pretty variable from one survey date to the next, which is to be expected. What I found amazing is that they've actually had a maximum of 25 salamanders under the boards during one check. So I would never have expected to have that many terrestrial salamanders in such a small forest patch in an urban environment and going to the boards. So unfortunately, we can't know exactly how many salamanders we have like across from one survey period to the next or trying to extrapolate to the park because we're not marking the salamanders. So all we can ever really do is look at the most we've ever found under the boards as a comparison at this point. This graph here is showing those 5 different transects. So we're getting quite a difference in numbers across from one side of the patch of forest to the other. So this patch, this transect here is closest to the road that comes in and out towards the school and to a park down below. So that's right near an edge. This transect is also near an edge, but that edge is a lot smaller, the gap, and there's actually a fairly large park close by on this side of the park. So that may be why this transect here has more salamander detections. And then this is looking the other direction, looking across the rows, and it looks like the transects, the rows that are more in the center of that forest patch tend to have more salamanders than the rows that are farther out towards the edge. So it's interesting. It's giving us some data that I think could be quite useful and definitely very interesting. The students are loving it. So combining that with some of my own personal observations, one of which was made at my old house. So this is where I used to live in Nanaimo. So you can see a very urban, very developed neighborhood. And I was removing some old rotted boards off of a concrete set of steps at the back of the house. And there were 5 terrestrial salamanders, wandering salamanders under the boards. A couple of them were juveniles, I believe. And I was absolutely blown away. What are they doing in an urban environment like that where there's no forest patches anywhere nearby? I don't know how they got there. The fact that there were little juveniles means they're breeding. So there's at least a number of adults there. Absolutely not expected. Whenever we talk about terrestrial salamanders, we talk about how sensitive they are, that they're only in forest environments. So that made me really wonder, how common are they in urban environments? How many of them are we missing? And then now where I live in more the north end of town, I do see them on the road on a regular basis when I go on my walks in the neighborhood. So, and we have had the public, members of the public tell us about salamanders they're seeing, including terrestrial salamanders on the road in different parts of the city. So it's got me thinking. I'm not too surprised in the sense that salamanders are not something that we think about very much. We don't see them. They're silent. They don't have breeding choruses like frogs and toads. They're very cryptic. They tend to blend in, they hide, and they don't move around very much. And of course, they're nocturnal. So we don't see them. Unless you're out with a flashlight at night, you're not going to see salamanders. So I find all of this quite interesting. But it does make me wonder, are we doing everything that we could be doing for potentially little remnant populations of salamanders that might be occurring within our urban environments that we don't even know are there? So NALT has built upon this cover board program with the students and expanded it out to members of the public, and they're offering up cover boards for a small donation of, I think it's only about $10. But they've also, I think, will give the design out so that you can make your own. And we just would love to see people putting these cover boards in their yards and checking them regularly and starting to get an idea of where the salamanders are in the city. And I'd ultimately love to look at those locations where we're finding salamanders and then look at what the habitat is like around there. Are they anywhere near parks or little sections of forest cover? Yeah, really fascinating. If you want to visit the Nanaimo Area and Land Trust website, you can get information about this backyard coverboard project. So what have we talked about today? Just to summarize, salamanders are amphibians. They're a very ancient vertebrate lineage. They have sensitive skin, which requires that they live in mild and moist conditions, or they're seeking cover to escape extremes in climatic conditions. We have both aquatic and terrestrial breeding species, which means that they need to be able to move between water and upland habitats. All of our salamanders are using these upland environments for foraging and for overwintering, but the salamanders need to be able to move safely between these aquatic environments and the upland habitat. Where roads intersect between those habitats, salamanders are going to end up having to cross roads, and that results in vehicle collisions. To mitigate the negative effects of roads, we can install underpasses for amphibians. They will work to some degree. They're not an absolute solution, but they do mitigate some of the negative effects. And then, as I was mentioning, I think salamanders might be a lot more common in urban environments than we think, and it would be nice to set up cover boards to do a more extensive inventory and monitoring of salamanders in the city. Thank you.